On the 11th day of Christmas of math nerd gave to me 1 ODE. It is day 11 of Mathmas, and today we're gonna go ahead and cover an ordinary differential equation, and we're actually gonna take an example from one of Nate Ramier's books. This particular differential equation is just so exciting because the way that we have to arrive at the solution feels like the tool itself just comes out of thin air. This is a differential equation we want to solve. We have y prime plus tangent of x times y equals sine of x, and we want to find the general solution for this, and we're going to go ahead and use something called an integrating factor. Okay, so here I have Nate Ramier's book, and let's go ahead and open it up and talk about when he mentions the integrating factor. So as you can see, we can have a first order linear differential equation. Typically, it has these notations. P of x times y is equal to some function q of x. And what we're gonna use is something called the integrating factor, which is this right here. So you have e to the integral of px. So we're basically gonna take this p of x value, whatever is being multiplied by y, and find the integrating factor and use that to find our general solution. Okay, so here's where we start. Our integrating factor is gonna be e to the integral of this function right here. That was our p of x. We're taking e integral of tangent of x. Now, just to go ahead and break it down, this is how we take the integral of tangent. I rewrite it as sine over cosine. My u term in this case was cosine. My du is negative sine x. Move that to the other side. Du over negative sine x is our new dx. So I go ahead and use that for that differential. This will give me an integral of negative 1 over u du, which will integrate to negative natural log of cosine x. That should have an absolute value right there. But what I like to do is I like to bring this over. So this is cosine to the negative 1, in other words, 1 over cosine, and that's going to be secant. That is gonna be secant right here. Okay, so then now I have my integrating factor is e to the natural log of secant x. Well, e to the natural log just cancels out, so we really just have secant. So now we are ready to go ahead and multiply the integrating factor to everything. And look what's gonna happen. This is gonna be the magic. We have y prime secant x plus secant x tan xy equals secant x sine x right here. Now, look on this side. This resembles the derivative of y secant x. You can sort of see this by using product rule, where you're taking y prime times the second function, and then the derivative of secant times y. That's y secant x prime. So all I have to do now is integrate both sides. This will go away because now we have the derivative. It just becomes the original function. And this was just the integral of tangent. So I just make it natural log of secant x plus your cheese. And now secant is 1 over cosine. So I just multiplied cosine to the other side. And now I will get the official general formula for this first order linear differential equation.